Probability of simple event. What do we mean by probability? It is a likelihood for something to happen. It also refers to the measure of the chance. We have different basic terms in probability. First, experiments. Experiments are the activities with observable results. For example, tossing a coin, rolling a die, spinning a spinner, picking a marble or ball from a given container or jar. Next is outcomes. These are the possible results of the given experiment. For example, in tossing a coin, the outcome can be head or tail. Next, it is what we call sample space. Sample space is the set of all possible outcomes of an experiment. For an instance, in tossing a coin, the sample space will be head and tail. And in rolling a die, the sample space will be 1, 2, 3, 4, 5, 6. Event. This is any subset of possible sample space. For example, in tossing a coin, the event that a head will occur, or the event that a tail will occur. In rolling a die, an example is the event that even number appears, or the event that odd number appears. Simple event. When an event involves a single element of the sample space. The probability of simple event, we have if an event E has number of elements in the given event, equally likely outcomes, and its sample space S has a number of elements in the sample space, likely outcomes, then the probability of the event E is given by this formula. We have the probability of the given event is equal to the number of elements in the event over the number of elements in the sample space. We have different properties of probability of a given event. First, a probability is a number between 0 and 1 inclusive. Next, the probability of an event that cannot happen is 0. Then, the probability of an event that must happen is 1. And lastly, if the probability of an event E is P, then the probability of the complement of E is 1 minus P. Let us have example number 1. If a coin is tossed 3 times, find the probability of getting exactly 2 tails, getting at least 2 tails, and getting no tails. So the condition here, we have to toss our given coin 3 times. So the sample space will be head, head, head. For an instance, on the first toss, we have head. Second toss, we have head. And then the third toss, we have another head. Or we can have head, head, tail, tail, head, tail, tail, head, 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 tail, head, tail, tail, head, tail, 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 and head, tail, tail. So with this given, we have a number of elements in the sample space is 8. Knowing that the number of sample space or the elements in the sample space is 8, let us answer the first given, getting exactly 2 tails. So from here, the number of the elements having exactly 2 tails will be 3. So we have our tail, head, tail, 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 head, and head, tail, tail. So we have here 2 tails to come up in the given elements. And knowing that the number of elements in the sample space is 8, we can find the probability by having the probability of getting exactly 2 tails is equal to 3 over 8. So we have 3 over 8. Next is getting at least 2 tails. So when we talk about at least 2 tails, it could be 2, it could be 3. So from our given sample space, the number of elements having at least 2 tails is 4. We have tail, head, tail having 2 tails, tail, tail, head, another 2 tails, and then we have here head, tail, tail with 2 tails again. And since at least 2 tails, we can also take 3 tails. So we can have tail, tail, tail. So again, we have 4 elements. So to find its probability of getting exactly 2 tails, so we have the number of elements in the given event, which is 4, over the number of elements in the sample space, which is 8. So we have 4 over 8, or this is simply equal to 1/2. Next is getting no tails. So in this given sample space, the number of elements with no tails will be 1, which is head, head, head. And to find its probability, again, we have the probability of getting no tails, that is equal to 1 over the number of elements in the sample space, which is 8. And that is equal to 1 over 8. Example number 2. A red and a yellow dice are rolled. Find the probability of the following events. So first, the event A, the yellow die shows 6. Next, the event B, the sum of the 2 numbers is 8. And lastly, the event C, the sum of the 2 numbers is less than 6. So we have a red and a yellow dice. For an instance, the sample space is this. So let us say the first number here will be the result of rolling a red die. And then the next number will be the result of rolling a yellow die. So again, we have the sample space 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Because again, in a given die, we have numbers 1 to 6. And then we have 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. And then we have also 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. So in this given sample space, the number of sample space or elements in the sample space is 36. Now, let us take the probability of having the event A, or that the yellow die shows 6. So in this given sample space again, if the yellow die will show 6, we have 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. So we have a total of 6 elements. So again, for the event A that the yellow die shows 6, we have 1 6, 2 6, 3 6, 4 6, 5 6, and 6 6. So again, for the probability, we have the number of elements having the yellow die show 6 over the number of elements in the sample space. So we have 6 over 36, and this can be simplified as 1 over 6. Next is the event B is the sum of the two numbers is 8. Given again the sample space, if we're going to take the sum of the two numbers is 8, we'll have 2 6 because 2 plus 6 is equal to 8. We also have 3 5, 4 4, 5 3, and 6 2. So we have a total of 5. So therefore, again, we have the event B having the sum of the two numbers is 8, 2 6, 3 5, 4 4, 5 3, and 6 2. So to get the probability of having the sum of the two numbers is 8, we have again the number of elements in the event B, which is 5 over the total number of the sample space, elements in the sample space, which is 36. So we have the probability of 5 over 36. And the next, if the event C is the sum of the two numbers is less than 6. So going back with our sample space, we'll have 1 1, 1 2, 1 3, 1 4, because the sum of these numbers, 1 plus 1 is 2, 1 plus 2 is 3, 1 plus 3 is 4, and then 1 plus 4 is 5. They are less than 6. So we cannot take 1, 5 because this is already equal to 6. We cannot also take 1, 6 because that is more than 6. Aside from this, we also have 2 1, 2 2, 2 3, 3 1, 3 2, 4 1. So we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So again, for the event C, we have 1 1, 1 2, 1 3, 1 4, 2 1, 2 2, 2 3, 3 1, 3 2, and 4 1. So we have a total of 10 for the number of elements in the given event C. Now to find its probability, the probability that the sum of the two numbers is less than 6, we have 10 over the total number of elements in the sample space, which is 36. So we'll have 10 over 36, or this will be simplified as 5 over 18. Example number 3. A committee of 2 is to be chosen at random from a group of 5 students consisting of 3 boys and 2 girls. What is the probability that a committee of 2 boys will be chosen? Or a committee consisting of 1 boy and 1 girl will be chosen. So let us find first the sample space. So we have B sub 1, B sub 2, B sub 1, B sub 3, B sub 1, G sub 1, B sub 1, G sub 2, B sub 2, B sub 3, B sub 2, G sub 1, B sub 2, G sub 2, B sub 3, G sub 1, B sub 3, G sub 2, and G sub 1, G sub 2. So from here, the number of the elements in the sample space will be 10. Now, if we have to answer the first question, that the committee of 2 boys will be chosen, if we're going to look back with the sample space, if 2 boys will be chosen, we have the number of elements having 2 boys, we have 3. We have B sub 1, B sub 2, B sub 1, B sub 3, and B sub 2, B sub 3. So again, the probability of having 2 boys to be chosen will be 3 over the elements in the sample space, which is 10. That is 3 over 10. And the next, if the committee will be consist of 1 boy and 1 girl. So looking back again with the sample space, we have a number of elements having 1 boy and 1 girl. We have a total of 6. We have B sub 1, G sub 1, B sub 1, G sub 2, B sub 2, G sub 1, B sub 2, G sub 2, B sub 3, G sub 1, and B sub 3, G sub 2. So we have a total of 6 elements. Now to find the probability of having 1 boy and 1 girl, we'll have the number of elements in the given event over the number of elements in the sample space. So we have 6 over 10, or this is simplified as 3 over 5.